Today we are going to be talking about variables and expressions. A variable is a letter or symbol that represents a quantity that can change. A constant is a quantity that does not change. An algebraic expression contains one or more variables and may contain operation symbols. So these definitions are going to be useful when we do the following examples. We can evaluate an algebraic expression by substituting a number for the variable and then finding the value by simplifying. Examples of algebraic expressions are 150 plus y, 35 times w plus z. These are algebraic expressions because there's no equal sign, also because they have variables. The variables are w, y, and z, and our constants here that never change are 150 and 35. Now these are not algebraic expressions because there's no variable in these examples. 85 divided by 5, we don't have any variables such as y, w, or z, so this is not an algebraic expression. And 10 plus 3 plus 5, once again we have all constants and there are no variables, therefore it's not an algebraic expression. When evaluating algebraic expressions, we're doing this because we want to find the missing values that are in the table. So in this example, we have an algebraic expression, w divided by 11. So we set up a table and we have our variable here that we want to find, w, and then we have our algebraic expression, w divided by 11. And when we plug in 55 for w, or substitute 55 for w, it turns out to be 55 divided by 11. Because right here, we're just substituting 55 for w. In this example, we are substituting 66 for w. So w divided by 11, where w is 66, 66 divided by 11, the answer is 6. When w is 77, what does the algebraic expression evaluate to? 77 divided by 11 is 7. In this example, we have a different algebraic expression, 4 times n plus 6 squared. We have to remember our rules for PEMDAS. Remember, it's parentheses, exponents, multiplication, division, addition, and subtraction. So first, we do parentheses, which when we plug in our 1 for n, we have 4 times 1 plus 6 squared. There's no parentheses. Next would be exponents, and we do have an exponent here. Our exponent is 2, so 6 squared is simplified to 36. So we put 36 in where 6 squared is, and now we do the next part. 4 times 1, multiplication, is 4. 4 plus 36 is 40. Now when n equals 2, we do the same process of substituting 2 for n in our algebraic expression, but we get a different answer. 4 times 2 plus 6 squared. Once again, we do exponents first. 6 squared is 36, and then we do our multiplication. 4 times 2 is 8. 8 plus 36 is now 44. Then, when n equals 3, we do the same process, and we plug in 3 for n, and we simplify. Our first rule is exponents. 6 squared is 36. And our next is multiplication. 4 times 3 is 12. 12 plus 36 now simplifies to 48. Now we can evaluate an expression with two variables. An example, a rectangle is 12 units wide. I suggest drawing a picture. So here's our rectangle, and it's 12 units wide, 12 units. And now it's asking us, what is the area of the rectangle if it is 4, 5, 6, or 7 units? So it wants us to find when the rectangle is 12 by 4, and the width is actually 2. That doesn't make any sense. So the width is 2. The width is 2 units, and our length is going to be 4, 5, 6, or 7. So we set up our table, and this time we include two variables. We have a length and we have a width. And our algebraic expression for area is length times width. So when our width is constant, because 2 units wide, it's never going to change. Our rectangle is always going to be 2 units wide. The only thing that's changing is the length. It's changing 4, 5, 6, and 7. So we can put 2 units in for all of our width, and for length we substitute what the problem asks us to solve for. 4, 5, 6, or 7. And now we have our algebraic expression, length times width, and we plug in our numbers for our variables and evaluate the expression. So length times width, where length is 4 and the width is 2, 4 times 2 is 8. When our length is 5 and our width is 2, 5 times 2 is 10. When our length is 6, these are units squared. All of these, and these are units. So, when our length is 6 units and our width is 2 units, our area, length times width, is 6 times 2, or 12 units squared. When our length is 7 units and our width is 2 units, our algebraic expression is 7 times 2, which simplifies to 14 units squared. Now we know that the rectangle will cover 8, 10, 12, or 14 square units. Finally, there's a trick. Not a trick, but something that we want to know, something that's useful. If you notice in the beginning of the video, I said something like 53x, and then I realized that it was 53 times 3. That's because x is a variable, but x is also the multiplication symbol. So when we are evaluating algebraic expressions, we don't want to get confused by x times x, because that could be times 3 or x 3. What does that mean? So when we want to convey that x is multiplied by 3, we can say that x is multiplied by 3 by using parentheses, or we can use a dot, x times 3, or for multiplication we can just put the number in front of the variable, and that signifies 3 times x as well. For division, we can use our fraction line, because when we say 1/2, 1/2 is really equivalent to 1 divided by 2. So when we have 35 divided by y, it's the same as 35 over y. So this is how we can write multiplication and division expressions without the symbols x and division sign.